Phenol. Acidity of phenol, alcohol, and water. Alcohol, water, and phenol have different acidity because they have different Ka values. Acidity increases in the order of aliphatic alcohol, means straight chain alcohol. The acidity is less than water, and water acidity is less than phenol. Phenol, alcohol, and water are considered as weak acid because they donate H plus ion. So, one H atom from water, from alcohol, from phenol is donated to become H plus ion. So if you look at the Ka value, they are different. So the Ka value for water is 10 to the power of negative 14. For aliphatic alcohol, straight chain alcohol, 10 to the power of negative 16. The Ka value for phenol, 10 to the power of negative 10. So this Ka value, the phenol has a higher Ka value. So phenol is most acidic if we compare with aliphatic alcohol and water. Phenol is more acidic than aliphatic alcohol and water because stable than the alkoxide ion. Phenol has stable phenoxide ion. This is phenoxide ion. The alkoxide ion is this, R attached to O minus, the R group, straight chain C attached to O minus. This is alkoxide ion. This is phenoxide ion. So phenoxide ion is more stable than alkoxide ion. The phenoxide ion form is stabilized by resonance effect. So this is a resonance effect in phenoxide ion, which alkoxide ion doesn't have. The ability to spread the negative charge over carbon atoms rather than concentrated it on just one atom produces more stable ion, means the negative charge, this negative charge is spread over all carbon atoms in the ring. Compared to alkoxide ion, the negative charge only here, only at O minus, but in phenoxide ion, the negative charge spread over the carbon atoms in the ring. So that what makes phenoxide ion more stable than alkoxide ion. Chemical properties of phenol. So phenol can react with sodium metal. It can also react with sodium hydroxide. Note that aliphatic alcohol, the straight carbon chain alcohol, cannot react with sodium hydroxide. Only phenol can react with sodium hydroxide. So this is a reaction with sodium metal. Phenol reacts with sodium metal. The Na replaces H atom and it becomes O minus and Na plus, half hydrogen gas because only one hydrogen. So half hydrogen, you replace only one hydrogen. So one hydrogen atom only. So that's why half hydrogen gas. So this is cyclohexanol. Cyclohexanol, Na metal replaces one hydrogen atom, becomes O minus and Na plus, plus half hydrogen gas released. Reaction with sodium hydroxide. Phenols are soluble in sodium hydroxide or it can react with sodium hydroxide, but alcohol with 6 carbon atom or more do not. For example, we have phenol and sodium hydroxide. The Na can replaces hydrogen atom in phenol, becoming sodium phenoxide, same as in sodium metal here, O minus and Na plus, sodium phenoxide as well if it reacts with sodium hydroxide plus water because OH reacts with H plus, so becomes water as a side product. But in straight chain alcohol, it cannot react with sodium hydroxide, so it is almost insoluble, so this reaction won't happen. However, if we compare the phenol and straight chain alcohol less than 6 carbon, for example ethanol, ethanol does not react with sodium hydroxide because ethoxide ion is stronger base than hydroxide ion, so reforming of alcohol will occur. So this is ethanol. If we remove the hydrogen, it becomes ethoxide ion, and for this NaOH, it will become OH minus hydroxide ion. So we have ethoxide ion and hydroxide ion. So ethoxide ion is stronger base than hydroxide ion. So this is stronger than hydroxide ion. So this ethoxide ion will react back with H plus. This ethoxide ion, which is stronger, it will react back with H plus, the acid H plus. So reforming of alcohol will occur when CH3CH2OH release proton or donate proton, it will become CH3CH2O minus. So this CH3CH2O minus, the ethoxide ion, is more stronger than hydroxide ion. It is a stronger base, so this base will react with the proton that is donated by the ethanol. That's why reforming of alcohol will occur. There won't be CH3CH2O minus Na plus. They won't occur. So no reaction if ethanol react with sodium hydroxide. Chemical test for phenol. There are two chemical tests can be done for phenol. First, we use FeCl3 solution and bromine in water. Phenol reacts with FeCl3 aqueous. It will form purple complex. This drawing means FeCl3 is in the benzene ring. It is purple complex. So it means FeCl3 won't replace any atom, won't attach anywhere. This compound is just in the benzene ring. If we use bromine in water, so the product will be tribromophenol, 2,4,6-tribromophenol. So the bromine, this bromine, it will replace 3 hydrogen in phenol. First, hydrogen number 2, hydrogen number 4, hydrogen number 6. So 3 bromine will replace 3 hydrogen, form HBr. So this is what precipitate. The FeCl3 in phenol is purple complex. So if we do chemical test for phenol, if the purple complex is present, so that means there is phenol in the solution. If there is white precipitate and HBr form, there is phenol in the solution if we use bromine in water. Thank you.